Welcome to World of DaaS, a show for data enthusiasts. I'm your host, Auren Hoffman, CEO of SafeGraph and GP of Flex Capital. For more conversations, videos, and transcripts, visit safegraph.com/podcasts. Hello, fellow data nerds. My guest today is Bram Cohen. Bram is the creator of the BitTorrent protocol and the BitTorrent software, which has been downloaded over 2 billion times. He's also the founder and CTO of Chia Network, which manages the cryptocurrency, which trades under XCH. Bram, welcome to World of DaaS.
Good to be here. Thank you.
I'm really excited. Now, you've been working on this kind of newer open source data science project called Benchmark Spaces.
Yeah.
Tell us more about that.
Well, I get interested in all kinds of random things. So this has nothing to do with BitTorrent or Chia. If anything, it has something to do with, I'm also a mechanical puzzle inventor. I have a lot of, I invent mechanical puzzles, and they're all very, very 3D. And I actually have a bunch of them that are in mass production that you can go buy in toy stores and stuff. But I don't usually do data science. And it doesn't generally come up in the rando things that I work on. However, I do all this like 3-dimensional reasoning and sometimes higher dimensional things. And there's a place where that becomes really important. So I had a thought on it having to do with clustering algorithms. So
Okay.
When you have some very high dimensional space, right? The classic one, I think the one which it really came from originally was for the Netflix prize, that you have this very, very sparse, high dimensional space of information about which people like which movies. And then you want to know, for a new person who likes these movies and doesn't like these other ones, which movies are they likely to like? And so the problem here is this is a very, very diffuse, very high dimensional space.
And it's just too hard to just do like a basic collaborative filter or something like that there.
The problem is doing correlations between things. You just don't have enough data.
Not enough information.
Yes. So what you really want to do is flatten this down into a much smaller number of dimensions, so you can just use a normal distance function to say how closely related things are. And it's very mathematically elegant to smush this down onto the surface of a sphere. And then you have to pick how many dimensions that sphere is. That's a whole other subject. But you do it on a sphere, and this works. And then you kind of say, okay, well, we're going to take, all the people represent points, all the movies represent points.
Now, for the people listening, they might not think of a sphere as anything other than a 3D. Can you just give us like a little bit back?
So you have this generalization of these shapes here. So in general, a sphere is all the points that are a set distance from some other point. So in 2 dimensions, it's a circle. That's a 1-dimensional sphere. In 2-dimensional spaces, it's a circle, right? In 3 dimensions, it's what people mathematically call a sphere is what you would colloquially call the surface of a sphere, and mathematically you call it like a ball or a disc, right? The whole thing. Yeah. But a sphere is just the surface. So you you can have in 2 dimensions, you have a circle, and that kind of forms this very trivial sphere that's equivalent to a bunch of other shapes because it's so simple. In 1 dimension up, if you're thinking 3-dimensionally, the surface of the Earth is a sphere, right? And people can walk around on this Earth and be distances from each other. And then you can.
But if we're adding like a 4th dimension, like time or some of these other things.
Well, it's not time because it's a really normal spatial dimension, right? If you're talking about time is sort of special because you can only go one way in time, and you always increasingly get farther apart from things. Where in a spatial dimension, you can get closer and further from things. Generally, the way you mathematically talk about larger numbers of dimensions is you talk about it just in a Cartesian way. You say that every single point is represented by a bunch of numbers, and the number of numbers is the number of dimensions you're talking about. And there's this really simple formula based off the Pythagorean theorem for telling you what the distance between 2 points is. So we talk about the unit sphere, some number of dimensions, it's all the points that are a certain distance away from something. This is a slightly magical way of defining things because it makes it look like all the ways in which reorientations are all kind of symmetric. seem to just sort of fall out of it magically when you use the Pythagorean theorem instead of using more primitive axioms and sort of deriving them. But it's easy when you're just programming it in a computer to do it that way.
Yep. So it's just a squared plus b squared equals c squared.
Yeah. To find the distance between 2 points, you take their distances in all the dimensions, the difference in the absolute value of their difference in all the dimensions, square all those values, add them up, take the square root. So,
interesting.
So just the normal Pythagorean theorem, there's only A and B. So it's a squared of a squared plus b squared. For more dimensions, it's just like a squared of a squared plus b squared plus c squared. It's for 4 dimensions. So very, very simple there. And it all kind of works a little bit excessively magically. This feels a little unmotivated if you just start with it, but it's very mathematically convenient when you're just programming stuff in a computer to work this way. So when you're doing clustering, the basic idea is you say, well, I have some number of points here, and they kind of want to be these distances from each other, right? There's a lot of nuance to exactly how you implement this. And a lot of the details can be better or worse. That's outside the scope of what I personally am super interested in here. But you say some points want to be closer to each other, some points want to be further from each other. We're just going to start by plopping these points down randomly and having them like push each other apart or pull towards each other and kind of all do this all at once, pushing and pulling through the whole thing. And make it so the amount that they're pushing and pulling goes down over time. This is a process called simulated annealing. The amount that they're pushing away from each other is called the temperature. And the idea is you start at a high temperature and gradually lower it. And if you do this on like a good schedule, it will tend to do a very good job of making all the points be the distances away from each other that they really want to be at the end of this process.
Now let's take up like one higher level because I don't know that like all of our audience is going to be able to follow everything you say here. And we have some super technical people, but we also have just like CEOs of data companies that are so why is this like why do we need more breakthroughs in data science?
Well, the thing that I have here, what I'm working towards is something very actionable, right? That if you have certain kinds of data science problems, like very specifically like movie recommendations, right? But other things along those lines.
Basically, where you have like lots of sparse information, lots of holes in the data set.
For those kinds of problems, it's hard to actually make good recommendations. It's like if you don't know what you're doing, you sit down and you start doing stuff. And if you just make stuff up without looking at any of the literature, you will make some mistakes that are sort of classic mistakes that are very, very bad. And I read people from time to time making these mistakes. So like one thing that people classically do is they put them in a cube. You say, okay, well, I'm going to say my points are in a cube. So each of the dimensions is between 0 and 1. And now they're going to push and pull each other away. And I'm going to come up with points in the end. And then I'm going to maybe try and give names to these dimensions and figure out what they mean. This is a very, very bad idea for a reason that's really counterintuitive, which I can explain. But the point being, it's hard to do. And so, and you want these like movie recommendations to be better, right? For whatever definition of better, you can come up with various metrics. They tend to all kind of give you similar results. So I have this like recommendation that I want everybody to hear where most people who have this problem can just like change a few lines of code and get slightly better results.
Okay. Got it. That's cool.
Yeah.
No, why do you think, I mean, just in general, it does seem like recommendations are not very good today in general. So whether it's, what products should I buy on Amazon, what movies I should buy on Netflix, Spotify seems to be like slightly better on the music, but still not that great.
There's a few problems that come up. One of them is if you're making recommendations within a pile of garbage, they're all going to be garbage. So that's there's some things which really, really suffer from that. But in other places, you have a few things going on. There can be some pretty serious misalignment between the interests of who's giving the recommendations and the interests of whoever is getting stuff recommended.
Because Netflix really wants to recommend their own shows.
Exactly. Yeah.
And maybe Spotify wants to recommend things that are like slightly cheaper for them to recommend or something like that. And
well, I think
Amazon
Spotify
might
has
want to
less
recommend
of these
things
problems.
with the best margins or something.
Yeah, but there's a lot of that going on in different things.
Yep.
And then another problem is just one of data. So as a general rule, better data will beat better analysis any day of the week. Like that's always going to be the case. And the main thing that makes data better is just like more of it. So sometimes you can have bias that's just data that's just horribly biased. And real data scientists actually don't spend most of their time doing really super fancy analyses like people imagine. They spend most of their time cleaning up their data, removing garbage and biases and all that stuff from it.
Yeah.
So something like Spotify has just a vast corpus of data. Like any one given person will tell it about generally hundreds of tracks that they like. You hit, skip on a whole bunch of tracks you're listening to, even if you weren't thinking about it and just listen to some playlist, right? Like things like that. And most people can just start naming albums they like, songs that they like, yada, yada, yada. And it has many, many other people who also have similar things. So the number of data points per person on Spotify is actually much, much higher than the number of data points per person that Netflix or like HBO Max
It
has.
also makes sense because like a song is 4 minutes long, a movie might, even average movie / TV show might be an hour. So you're just going to consume a lot more data points over time.
Yes. Yeah. Yeah. Things that really have a lot of data are like social media, which really has on the granularity of like individual pictures that you look at and interact with.
But even there, like the ads you would just think the ads would be better, but they're not that great, right?
Well, what do you mean by better? What are you optimizing for?
Well, optimizing for showing you things that you're likely to have high interest in.
But you have to multiply by a few other things here. You're taking your interest times the likelihood of it resulting in you taking an actual action times the amount of money that the advertiser is going to make off of that.
Sure.
So what you think is good and what the platform thinks is good might be highly divergent. Also, a lot of these platforms suffer from not getting very many good advertisers. There are things that monetize better, but have either one of two issues. Either the advertiser has an issue with the platform, or the advertiser has an actually good product and doesn't need to use the platform. It's a classic issue. eBay at one point just tried the experiment of turning off all advertising that they were doing for a day, and their monetization did not move an inch. And they're like, well, why are we doing this? And they just stopped doing it completely. Because if people wanted that stuff, they were going to go to eBay, whether eBay advertised it or not.
Yep. Tesla famously doesn't advertise.
Mm-hmm. Yeah, the guy from Alienware said, marketing, I'm paraphrasing, but marketing is the price you pay for being uncool.
Yeah. And so where do you think we are in just this, like, we've kind of hit some sort of data science revolution every single year. It seems like there's all these new tools. There's all these, that have been built for data scientists.
Yeah.
There still maybe isn't as much great data accessible for the average data scientist. Like, do you think we're at like point where like the tooling is 80% good enough and we just need a little bit better, but we still need a lot more data? Or where do you think we are in this kind of evolution?
Oh, well, that's a very broad question, and it has to do with what specific thing you're talking about in general. Like, a lot of why like chatbots work so well is because they have the internet. They have these vast corpuses of text to analyze and mimic for the most part. And if you did not have those vast corpuses of text, they would be nowhere near as good. And the vast majority of the time, when you ask it a question, it's just going through its memories and trying to find something where someone said something similar to what you're asking and just paraphrase them, which is what 90% of everything I say is anyway. I'm just
right, totally.
So definitely these like vast data sets are very important. The importance of analysis really depends on at what point you really hit a plateau in the quality of your analytics, right? For most real world problems people hit, you can just like do a linear regression and you're good, right?
Yeah.
For most of what's left, you like do you do random forests and you're good, right? Like you're the amount of extra utility you're getting out of adding a lot more horsepower to most types of problems tends to be very, very small. You're really squeezing blood from a stone, except for some specific weird things that can happen. There are exceptions to this, having to do with data that's very, very hard to analyze, like pictures, right? Like it's very hard to say, like, is this a picture of a person, right? Even a simple question like that. If you say, I allege that this is a picture of a person, it's like, well, can you give me scientific evidence that this is a picture of a person? It's like, well, look at it. What are you talking about? This is obviously a picture of a person.
But I mean, if you had a million labeled photos of cats and no cats or something like that, you would think that could train something. That's just data, right?
Yeah. It turns out even getting good data sets is really, really hard.
Yeah, it's expensive.
It's really expensive, and munging your data can ruin it in ways that you really don't expect. So you get things like deep neural networks are really, really good at detecting Photoshop. And so if you try and do image processing to make a new data set, well, you might have made a new data set that's actually quite good if you have humans that you're training. It's very, very bad because the deep neural network will just like learn to notice your Photoshop artifacts. And work off of those.
Now, speaking of these neural networks, these LLMs, like you built a product, BitTorrent, that had kind of massive impact on the entertainment industry, and it really created all these like conversations about copyright. And we're kind of in this new conversation about copyright with AI. Like, how do you think that's going to play out?
Well, a lot of, as you might expect, I'm not very big on copyright just in general. It's trying to enforce something that can't be enforced, so you just shouldn't try to do that. But a lot of the pretense of copyright, and actually patents are far worse for this, but a lot of the problem with the pretense of copyright is it assumes things are expensive to make, right? It's hard to make movies, it is hard to write books, it is hard to produce music. These are difficult and expensive things. And that has been changing over time, that these have been getting cheaper and cheaper over time. And for certain types of things, we are getting to the point where they're essentially free, where even someone having a copyright on images in particular is going to be fairly meaningless, because the way anyone who wants to will dodge around the copyright on an image is they know what they like about a particular image. They, kind of get a reference out of it, something like that. And they will simply make another comparable quality image because it's really, really easy to do. And the tools for doing that are getting much, much better very rapidly.
It seems that like, if you just, there's this recent Supreme Court case on this like Prince, Andy Warhol kind of drawing off of a photo of Prince, and it seems like the Supreme Court at least is not necessarily understanding all the new tools that are happening out there. So we could be in this muddling situation
the
for quite a while.
Supreme Court are a bunch of people who are really old. What happened after BitTorrent had been around for long enough is the content industry figured out that trying to say, no, you can't have a legal experience for this particular work online at all. You have to go to a movie theater, you have to go somewhere and buy a DVD, you have to do something that's several orders of magnitude more effort than it should be. Right. And if you do that, you're going to have a lot of piracy, and that's your fault. Right. And it took way too long for them to get with the program because they have a money machine. They don't want to rock the boat. They want everything to stay what it is. And copyright doesn't have a you can't be ridiculous component to it. Right. Like you have absolute rights over your stuff. So eventually they figured out, maybe we should actually make it so they're convenient, good, legal experiences for our stuff online. Unfortunately, they kind of got tricked into it. There's this whole weird thing where like Stars had paid a lot of money for contracts that were meant to be for cable but happened to cover the internet too, and Netflix just bought Stars. And as a result of which Netflix had a really good catalog and was a really good experience for a while, and then that contract ran out and now everything sucks. So it's been getting worse again over time.
Now, at one point BitTorrent was like 50+% of all internet traffic. Like what was the experience like, and do you think there'll ever be anything like that again?
Well, movies are very large, right? And so you have this tool that's just meant for like pushing around big data. So like a lot of stuff goes over web browsers now. I think these days an awful lot of the traffic of the internet is actually security cameras uploading what they see all the time. That's a
interesting.
That's like actually most of it,
because everyone has so many security cameras. They've got their Nests and their Rings and all those things.
And these are just 20,
and they're super cheap.
Yeah, and these are just 24/7 uploading stuff. You have this capacity. It's essentially free, right? Like things have gotten a lot cheaper over time. So it's. So that kind of speaks to, you get a little bit of a plateau in terms of the utility of internet connectivity. You can only use so much internet connectivity particularly usefully. And a lot of people are there. There's a lot of issues with internet connectivity in general. It costs more than it should. The big problem actually is much more greater latency than it should, which drives me insane. But I think that's kind of hit its plateau in some sense. I don't think we're ever again going to be hitting the like it's really hard to move big data files around problem. At least with current technologies, we've kind of hit the limit of consumption of them, because a human can only view, like, if you can stream like 16K, you're good. Like a human can't use more data than that in any meaningful way.
This idea of BitTorrent, like where people are using their own machines in kind of a decentralized way, and you had kind of like Skype kind of came out of that in a way. There still doesn't seem as much where like my machine is mostly dormant. My laptop, my desktop, even my phone is mostly dormant. It's plugged in at night. It could be doing all these useful things.
Well,
but
well, cryptocurrencies come in here.
Sure.
So for Bitcoin, Satoshi Nakamoto had this idea, had this vision that he explains in the Bitcoin white paper, where he thought, I think the phrase he used was one IP address, one vote doesn't work, but maybe one CPU, one vote can work, right? He had this idea that Bitcoin mining would be dominated by the sunk cost of fabricating CPUs, and just when these CPUs weren't doing much of anything, they could be mining Bitcoin, and this would be great. This is not how it worked out. Right? Like in the real world, Bitcoin mining is done by custom hardware, because that has 4 orders of magnitude advantage over general purpose CPUs. And it's all done, and most of the cost, even then, is going to power, and it's all done in facilities which have very cheap power, with stolen being the cheapest you can get. And it's pretty centralized in a not very large number of facilities doing that. And I don't like this personally. I view this as kind of gross. Having things that are, secure distributed systems is great, but you would like them to be more secure and more distributed and less wasteful. So,
but how come there hasn't been like, there's SETI and stuff, which was kind of like that. It was a distributed system that was, in the 90s, it was cool. I had it on my machine, in the 90s. And but there doesn't seem like today, like the average person is putting something on their machine and then using that compute power either to make extra money for themselves, or for some sort of societal good.
Well, I have something for this. It's limited, but it's something.
Okay.
So the issue is to have something like proof of work, right? To have something that's running a consensus algorithm. There are other things you could do, but they tend to consume like actual power. It winds up being your big issue. That often often things are either dominated by
and they're also just doing something isn't useful. It's just like it's like solving for weird prime number stuff.
Yeah.
Like that's like in the end, like that's not that in itself.
Yeah. Well, there
useful.
are the most useful ones I know of is there's like chess engine training things. The Leela Zero and Stockfish have like vast networks of volunteers who train them as they run these experiments. So that's kind of cool. Those have the problem that today the physical hardware for doing them is ludicrously more effective than the CPUs. A lot of machines in the future are going to come with custom hardware, which does do deep neural network stuff pretty well. But if you want something that's a little more mass appeal, the big problem is you don't want to be burning up your CPU here. You don't want to be burning real power. That does cost you something as you're doing it. And also, as much as I was poo-pooing, the cost of bandwidth, you don't want it using up a huge amount of bandwidth either, right? So I even answer for this specifically in the form of how to do better consensus algorithms, which is the worst offender right now in terms of burning stuff up for no reason whatsoever. Well, not for no reason, but you want to do better. So it's hard to do this. The problem space, the kinds of problems you want for proof of work, are not normal problems. They need to be things where they're kind of like lottery tickets, and they're like perfect lottery tickets. Like nobody can gain advantage over anybody else. And when you get a good ticket, you're not any closer to a better ticket related to it, and you get no economies of scale from these things. And it actually being useful for something really practical is actually kind of a downside, because some people might have that problem and just kind of get the thing as a side effect. So this is so this is highly problematic. And these do not make good problems. They don't make good puzzles. They're sort of intentionally fair, which makes them intentionally useless. But you can at least say, well, how do we not burn power doing this? How do we make it not wasteful? And and the answer is you have to use proof of space. That you want to get off of custom hardware burning power. And what you can do is have storage capacity, which is completely commodity. Bits are bits. They're exactly the same everywhere. Just nothing has a different API for them. And you want them to be just kind of sitting around board, right? So at a high level, what you do, and Chia, the cryptocurrency I've created, its consensus algorithm is based off of this. At a high level, what you do is you have some machine that has extra storage capacity in, because like your laptop probably has a lot of space you're not using. Excuse me, I have to plug it in here, or my computer's going to die. Okay. You have this. There we go. You have this extra capacity, the storage capacity that you're not using. So what you do is and I'm going to lie to you a little bit here, but bear with me. What you do is you take a whole bunch, you pre-print a bunch of bingo cards, right, that have some number on them, right? And then you just store these on your drive, and you sort them, which you can do in advance. So you can do quick lookups on them, right? And then the network as a whole is going to come up with challenges, right? The last block is going to get finished. Its hash makes a new block. Everybody goes and looks up that hash on their local machine, which they can do very quickly because they sorted everything in advance. And whoever has a bingo card that's closest to the one that just came up wins. And that's how the consensus moves forward. And you use this as a basis for a Nakamoto consensus, and presto, you have a secure distributed database that's a lot more secure and distributed than it would be if it were using proof of work.
And because it's pre-sorted, like it doesn't really take much CPU to go look these things up. It's really just the fact that they have them on there. They already have them.
Yeah, you did a one-time process.
And it's unique on each person.
You did a one-time process to get it set up at the beginning, and from there until the end of time, it's just sitting around board. So So now,
and it's somewhat dynamic as you add space or remove space.
Yeah. So that you have to have work difficulty resets, and things like that. Now, I just lied a little bit in what I said, because they're actually, if you verbatim use what I just said, there are really horrible things called Hellman attacks that people can do, where they can manage to use extra CPU to get unfairly more effective space out of the space that they actually have. And there's this whole long thing of like how you go about stopping those attacks. And this is all a long, very interesting thing where I personally actually came up with the construction that we're using. And it turns out you also need proofs of time that get thrown in there, and you're using proofs of space and time. Yeah, whole long involved thing with a complicated construction and reasons why it's all very necessary. In the end, it winds up looking kind of like it did at the beginning. If you just pretend like it works the way I said, your intuitions about its general behavior are going to be mostly right.
And why are, like, from like back in the day with BitTorrent, I understand like why decentralization was so important. But today, why is, the core tenet of many of these distributed systems is that they're decentralized. Why is that so important?
Well, we're like working on tokenizing carbon credits, for example. I know, unfortunately, there's a distinct lack of real world use cases for a lot of these things. But as an example, when you're tokenizing carbon credits, there's a lot of countries in the world that have the rights to have carbon credits. They don't really trust each other to be the ones who are keeping track of these things. They don't trust any one like financial institution to be the keeper of who has how many credits and keep track of all that.
Why not? Like, well, I mean, they trust every financial institutions for lots of other stuff, ratings and other things.
Financial institutions charge them way too much and screw them over eventually on these things. Like, once someone is the holder of a marketplace, they're kind of the center of the marketplace forever, and can just start charging way too much and screwing people over. And these are these are countries that don't trust banks. they regulate banks. They don't want to be beholden to banks.
Well, you can have a arbiter of a credit, and then it can be traded on many different marketplaces. You could trade stocks on many markets.
Yeah, so that's
right?
So the idea is you want like a secure distributed database that goes cross everything, that everyone agrees is a secure distributed database. And actually a blockchain,
I still don't understand why like, I don't understand why it's good for, like, I understand the use case for carbon credits, but like, I don't understand why it's better for carbon credits than for some other, for bonds or, property rights or, some other random
some
thing.
Of these things are highly regulated. So carbon credits tend to be issued by like countries, and they makes the rules. They can do whatever they want. Equities, it's generally illegal to just tokenize them and put them up and have people trading them, unless you jump through some legal hurdles, which are still being sorted out.
Sorry, but maybe I'm like, it'd be helpful for our viewers as well. So but why decentralization? Like, why is that so important here? We're generally my guess is most people who are buying and selling carbon credits are living in fairly, first world countries with lots of money. They're already trusting lots of the core institutions. Maybe they shouldn't be.
Well,
but they are. Right?
You want,
like, they're already doing for all their other financial systems.
Well, it's actually
like, why
decentralization is really, really good for just basic payments, actually. But I didn't want to start there. So it's also good just.
Is it only good for basic payments just because like everyone else is charging too much money?
Well, everyone else charging too much money is a big deal. That's really important. Like, why do banks make, like, why does Visa make almost as much off of a grocery store as the grocery store does? That's crazy. The margins for the grocery store are similar to what they're paying Visa.
Well, it's not only Visa, right? Visa is actually they're actually taking less, but the bank takes a lot because the bank often is taking a risk on the credit side.
Well, they're taking a risk because they don't want to fix anything, right? Like the goal here is, how about we make it so that when you make a payment at a vendor, you're using public key cryptography somewhere in there? Can we make that happen? Can that be a thing? Like, this is just good. People do not appreciate.
But it doesn't seem like today there's much peer-to-peer money movement using decentralized systems today.
Well, yeah,
in some rare cases, people are paying each other in Bitcoin or something like that. But often because there's a currency risk or some other reason.
You have a currency risk when you are paying someone in this like weirdo currency that's only used for this like transfer thing, right? So people don't like doing that. And then there's on-ramps and off-ramps from the financial system. And this is where you get some technical problems showing up, that the payment system, in order to route through the middle, right, has a lot of credit lines going all the way through this thing.
Yeah.
And things eventually get settled out later. But there are mass quantities of systems in place based on heuristics for detecting fraud and long-term relationships and things like this to allow those credit lines in the middle to work pretty well. The credit card companies like bragging about how little is lost to fraud, but what they're really bragging about is how little fraud is costing them. You, the consumer, are paying in every transaction for these ridiculous systems when there are better technical solutions.
Yeah, I mean, look, Visa is the best business out there, right? It is just extraordinarily profitable. They probably have 5x the number of employees they need.
Yeah.
And because they actually have to have more, because if they had as little as they could to run it, like the government would shut them down because it's just too profitable. Yeah. So they just spend money on like random things all the time, even on advertising. They spend money all the time purely to make themselves less profitable.
Yeah. Well, right. So the system is ridiculous here, and so there's different levels of things getting in the way of change. One of them is technical things. So if you do things like the blockchain way of doing this, you have this problem that you're not running credit lines everywhere, which, so how do you do that? And it turns out there are ways of doing this using payment channels, which then results in this problem that, okay, now you need to have liquidity providers in the middle. But that's very, very different from being someone doing credit scoring on people and things like that. So that's a bunch of technical work that hasn't been fully hashed out yet to really make blockchains scale. But that's sort of secondary to why would you want to use a blockchain here, right? And the answer really is a totally reasonable, although very pedestrian answer, which is simple payments cost way too much, right? And they cost so way too much that cryptocurrency is already getting used for like international transfers and remittances and things like that, just because the amounts that Western Union charges aren't merely too much, but just highway
and
robbery.
Sometimes the cryptocurrency might cost you 1%, but the remittance costs you, many multiples on 1%.
The remittance will cost you sometimes 5-10%, just crazy amounts. And these are poor people paying this. This is just messed up. So, and actually, sort of an unsung benefit to Ecuador's little experiment with Bitcoin, which did not go so well. But one thing that it did, one reason why it was kind of disappointing is that they made this whole setup. They're like, hey, we're going to make remittances a lot cheaper by allowing people to do them with cryptocurrencies and get it set up so everyone can do them with cryptocurrencies. And they basically did. But then people didn't use it because the costs of remittances went down. And so people didn't use it. And this is portrayed as a failure because people didn't do a lot of cryptocurrency remittance payments, where it's like, wait a minute, you scared?
Because the market responded.
Yeah, which is great. Everyone saved money on their remittances. That was a big success. It's
but it does seem like blockchain crypto, it's like this really amazing technology still looking to help society, and there's been a ton of effort in it. So many smart people. I mean, we're billions of dollars, and yet it still seems like we're still in the very early days of it actually helping people.
Yes, that is definitely true. That's absolutely the case. I'm working on it. Right. And, people in the cryptocurrency industry often think you're being a troll when you're like, years ago, I was like, okay, well, what are the actually useful smart contracts? Can you tell me a useful smart contract? And people thought I was being a jerk and a troll. I'm like, no, I'm actually asking. I really want to know. Can you give me suggestions?
Yeah, I would love to use it as a smart contract. It sounds so cool. It sounds so interesting. I just and I'm a fairly technical person. I've never actually had even the opportunity to even on the other side, even someone proposing a smart contract for something we're doing.
I can tell you a bunch of things. And some of the ones that I think are most important are like really pedestrian and prosaic, and people just like roll their eyes, whatever, right? Like what people want out of smart contracts is more Ponzi schemes, right? They want really sophisticated and basically illegal for good reasons mechanisms for people to Ponzi. But like your sort of fundamental beachhead thing, I think, for smart contracts is custody, right? You want, like when you use a bank, there are all these limitations that bank puts in place of like how quickly money can go through the system and under what circumstances certain things can be reversed and yada, yada, yada. And these are real security services that they're providing. They're doing it in a way that has no transparency or end user control whatsoever, and that scam artists totally take advantage of. Yeah, if ever anyone from Africa says, "Oh, hey, I paid for your conference, but I can't come. Can you give me a refund?" Don't give them the refund.
But like in the title world for real estate, in certain states like Massachusetts, like there's kind of a racket. Mm-hmm. If you're a lot of state senators happen to run title companies in Massachusetts, because there's like a whole racket there and it's just a great way of printing money for yourself.
With title, depending on what exactly you're referring to, there's a few different things going on. So like
just the local real estate.
There's like title insurance, which is just a racket. You're just required to make a donation to the local bank when you purchase real estate in the form of title insurance. And like this is an issue around things that happen. That one's particularly bad, but things that involve escrow in general are kind of ridiculous. That like, escrow agents, they keep 1% and they do diddly shit. And I've had the experience of calling an escrow agent and going, "Where's my fucking money?" And they like didn't know what to do, because like they had never had the experience of one party to a transaction fraudulently claiming that money should be returned when it should be put forward to the other side. And they just were utterly unprepared to deal with this situation. They just wanted to collect their money. Which is kind of like, why are we paying these people all this money to do nothing? And then they stopped calling me back. I think they were terrified. They were not used to a very angry entrepreneur calling them. So that's another good use of blockchain. So I keep starting to explain things and then we go on to other things. So two big things I'd like to explain are custody and escrow, right? So as I was explaining, your bank does do some custody for you. Not great, but they do it. And Bitcoin generally feels like carrying around suitcases full of $100 bills, right? Like it's kind of bad about these things. It's very cash and carry. However, there is the potential here, and I've done some work on doing this, to make it so that you can just program whatever custody arrangement you want and do it in a way that has complete transparency and end user control over exactly what's happening, right? And so the simplest, most basic thing, which is not standard, which is just crazy, is you have a multi-sig, right? There's some vault that there are 5 keys that can be used to open it. And you just have this rule that whenever you try to take funds out of it, depending on the number of keys that were used, it might get slowed down a bit in the process of doing the withdrawal. But that time is used to enforce the rule that an equal or larger number of keys can undo any attempted transaction, right? So if somebody gets their hands on like 3 of the 5 keys, but then the honest signers who actually should have control of it still have copies of those 3 plus 1 more, they can like up the security level to require 4 and kick the fraudsters out and then roll the money to something else. Just okay, that's really basic functionality, right? That's nothing crazy, and yet that's not. People aren't even working on that. So we have built that for our own at Chia, our own internal custody solution, and we are in the future going to make that like properly productized and like a good product for anybody to use. And this is something where instead of this being like an esoteric thing, like this would totally make sense just as a cost-saving measure for even like big companies to just use this for their internal custody of their own funds. because they're already paying banks a lot of money to help them keep track of their own money. You can save a lot of money using a blockchain and have a lot more security on it in the process.
Is there a scenario where, like, today, if storing, it's very hard to store data in a cloud in an encrypted way. Let's say I want to store my whatever photos, but I don't want people being able to see my photos or something like that.
That's well, I mean, different services do this differing amounts. Like, I'm not sure what they're doing.
It's not built into the basic services.
Well, Dropbox,
so if you're on Dropbox or Google Drive or all these other places,
Dropbox was just outright lying about this for a long time, where they claimed to be encrypted in everything, but they also said they were deduping. It's like, well, if you're deduping, you know what the file is, right? You can't claim to. And then they were charging.
And it becomes harder to do it if you have multiple computers.
Well, and then they were deduping on the back end, but charging people for multiple storage on the front end, which is just crazy town. But that's
interesting.
It was very, very bad behavior on their part. The basic tech for storing something that you're keeping offsite is very, very straightforward. You have to do key management on it.
But I understand the basic. It's straightforward for a software engineer, but it's not yet straightforward for the average consumer.
Vendors, there are certain kinds of services, particularly around privacy, but security in general has this problem that people can't tell if the service they're getting is any good. And so they often get services that are extremely bad. and it's just viewed as a marketing point. Yeah, we have security. See, checkbox. Here, I put a big
but even when everyone says it's good, people will say, like, a YubiKey is good. But if you've ever tried to, do the whole YubiKey and put it on your computer, it's a nightmare. It's like the UI is terrible. It's probably the easiest one to do.
Yeah, well, a YubiKey acts like a physical key, right? Like you want to log into a website, you pull it out of your pocket, you stick it in your computer, you log into the website, right? Like that's YubiKeys are great. Actually, I use them wherever I can. And it's utterly infuriating to me that, like, banks will force you to use a phone number. They just require a phone number, like, on it. Which is the most insecure thing. Like, there's a lot of telco providers where any random hacker can just call and ask nicely for them to jack your phone number, and they'll do it. Like,
it's happened to many friends of mine, for sure.
So, and of course, the rando consumers don't know which telco vendors do this and which don't. So. And telco vendors don't, and this is not widely known information. Just FYI, Google Fi is pretty good about it. I'm not sure which other ones are, but that's.
There seems to be, like, a Laffer curve for hyping technology. Like, too little hype is bad, but too much hype is also really bad. Like, have you think we've reached? Do you think there was a point where we just had, like, just too much hype on the crypto side?
Well, it's definitely taken a lot of people's money. There's a lot of just outright scam artists who have been very enabled by it, and that's really, really bad. There's a lot of smart people in it, a lot of people who pretend to be smart, and all of these people aren't. Even if they are smart, they're not the most ethical people in the world. If you look at the history of different technologies that have caused a big hype cycle, like there's been, the internet, right? There's been quantum, there's crypto, there's
now AI.
There's AI, right? Meaning AI, really meaning deep neural networks. I don't think people are actually that excited about machine learning and this clustering stuff that I'm excited about. That the general public's not. It's deep learning that people are excited about. So if you look at the previous hype cycles with these, they vary a lot, right? That, like, quantum got not as much hype as some of the others, but really hasn't led to much of anything. I don't anticipate it ever will, but it's interesting, right? Like, the internet definitely had a hype cycle, and it definitely crashed and burned, but it became so successful afterwards that that crashing and burning just looks like a blip in the history at this point. It's just like, just whatever. Crypto has had a big hype cycle and is so far crashing and burning. I think it'll make a resurgence. Not quite the same scale as the internet, because even if it completely takes over everything.
But remember, the internet, even when it crashed and burned, was becoming essential in everyone's life. So it was crashing from like a monetary standpoint, like the value of Priceline or the value of Amazon at the time was going down in the year 2000. And a lot of companies were going out of business, but from the everyday person, it was actually becoming more useful every single day. That has not yet been true with crypto.
Yeah. And crypto's potential, I think, is massive, but it's like, even if every single form of payment in the entire world moves over to being on crypto, that's not as big as the internet is. It's huge.
Correct.
It's not as big as the internet, right? But that's okay. You don't have to be. If you dwarf Amazon,
it's hard to be as big as the internet.
If you dwarf Amazon, you're doing pretty well, right? Like this is not. But interesting thing with AI is, unlike some of these others, AI is having like very real, tangible benefits today, right? Like ChatGPT, like really was this. It was this inflection point. I hate to say inflection point because my calculus brain knows what an inflection point is, and it isn't actually that. But anyway, there's this really big change that happened with ChatGPT, where all of a sudden it went from a curiosity that some people were using for some things to something that the general public was really excited about, and really excited about because they found it actually useful. It's a thing that they can actually pick up and use today and get just immediate tangible benefits. And it's amazing. Yeah, and it's one of these things where it's not super clear what the monetization is, except doing it software as a service seems to work just fine, right? Like, and how defensible of a moat that will be, we don't know, but it seems quite likely that this will be something where there might be several different ones that have their pluses and minuses. And
well, there's a lot of innovations that really not that many people ever really made any money from. But still super value for society. And I'd rather have those than have ones that both people don't make money from and not valuable to society. Right?
Well, often people making money, people have made a lot of money off of crypto, and that's kind of in many cases very bad.
Good point.
Because of the form in which the profiting has taken, of just fleecing people, basically. The amount of profitability has to do with the friction, right? Which is very different from the amount of value. Like all other things being equal, you kind of say, well, if everything stays exactly the same, something becomes twice as big, there's twice as much profit. But that's not the way things work. Sometimes something becomes bigger because the amount of friction goes down, and now it's creating a lot more value and making a lot less money. This is why we have academia, is so that people who are very smart are free to be inventors and work on things without having to worry about what is the monetization on this thing that I'm building that's of value to society.
Now, it's been kind of a wild few months in the U.S. banking system. We've seen the collapse of SVB, First Republic, Signature. There's calls for changes in FDIC. Like, what's your take on it in general?
Well, about those specific things that you just said, I have a very, what is in the finance world, a very just uncontroversial take, which is we basically have the Greenspan put on the marketplace, and we have for a very long time. And there's been this...
What's that mean?
If a bank goes under, the Federal Reserve will step in and backstop all their debt.
Got it. So it goes back to Alan Greenspan.
He just did this all the time. But this was very ad hoc when he did it, and it's become much more institutionalized now. But
even back in savings and loan crisis when he was chairman of the Fed, this was like a Greenspan put.
Yeah,
like
it's the term that they use in finance is the Greenspan put. Because in some sense, the Federal Reserve has bought everything already. So this is clearly a good thing, right? In at the start of the Great Recession, we did this little experiment of saying, well, we really want to have the incentives of banks to not get screwed be put off on their depositors. So we'll just let Lehman Brothers go under. And oh boy, that was not a good idea. We think the market can handle it. It's like, no, the market can't handle it at all. So the only way to fix this is that anything that's a bank or acts like a bank, and it turns out the way... anything that invests long and borrows short is a bank, basically. You put deposits in your bank, you are in some sense loaning the bank money. It's going and putting this into long-term assets. It has exposure to long-term things, but it could get a run on the bank at any moment because of the way it's set up. Anything that kind of looks like this is a bank, effectively. So you really kind of need a regulatory regime where anything that really acts like a bank has to be subject to constant auditing. And if its books don't close, it's immediately put into receivership, and the federal government immediately takes it over. And this has been kind of de facto the case to varying degrees in various places, but should be more official. And also FDIC insurance, in the same way, it has been not officially extended to all deposits, but as a matter of practice has been, with the exception of non-U.S. subsidiaries. Interesting stories there. But this should be done officially. That FDIC insurance should not be limited to $250,000. It should just be unlimited. Because what happened?
And what looks like a bank that isn't a bank?
AIG was the big one at the beginning of the Great Recession.
But today, what would you suggest? What class of things are out there?
I know about this from reading books about the Great Recession, so I can't really speak to the current state of things very well. But SVB was kind of a weird bank because it had all these depositors that were very sophisticated and weren't FDIC insured, right? So if you're maybe this is exactly the case where people should audit the bank and make sure that it's behaving well and have the depositors be somewhat responsible if the bank is misbehaving. And so we've done an experiment of finding out what happens under those circumstances. And it turns out the depositors don't audit the bank. They just do really, really fast runs on the bank when they think there's a problem. And
in SVB's case, it was actually a weirdly slow run on the bank because the run started in kind of October 2022, where lots of people had big deposits, were moving their money to sweep accounts, which were actually controlled by places like Morgan Stanley or other places.
It was started at some rate, but they kind of got in trouble. And the story is that there was one day where it got really bad, and it's sort of at the end of the day, they were kind of dodgy, and maybe they managed to pull together the funding the next day to fix it all. And then Peter Thiel got wind of this and just mailed all his portfolio companies and was like, hey, you should probably pull all your money out of SVB. And the very next day, $42 billion were withdrawn in one day, which is not good. And they had
basically my contention is it's not a classic run on the bank because yes, it happened in one random day in March, the bank, but it would have by June, it would have gone under anyway, because everyone was slowly pulling out their money anyway, because they weren't paying the interest rates that you needed. That at the time the interest rates were 4.5, they were paying 2. So that's a pretty expensive checking account to have if you have $20 billion or something.
The other side of it is they had done something kind of dumb, where they had just way too much exposure to long-term interest rates, just crazy exposure to long-term interest rates. And this is a very common thing in finance, that if you have a lot of exposure to the long-term rates,
but SVP historically always paid very low interest rates.
That's because interest rates were very low. There was a whole long period after the Great Recession where federal interest rates were no longer zero, but consumer interest rates were still zero for a really long time, which was kind of messed up. It was just whack.
But but historically they paid lower interest rates than a typical bank. And the reason is they said, well, we give you all these great services, and so they were kind of a premium price for a checking account because they gave you all these services. Now, but if when interest rates were 1% and they're paying you 0.5% or something like that, maybe that 0.5% difference wasn't that much to worry about for that checking account. But when it started being the spread being 2%, now maybe even 3%, now it's whoa, I'm paying $1 million for a checking account. That doesn't make any sense.
They needed to. They put themselves into a corner because they put so much stuff into long-term interest rates, into long-term, treasuries, when interest rates were very low, that interest rates went up, and now they're just insolvent, just totally insolvent. And that makes it so and if they had lowered their profitability, that lowers your solvency even more. So,
correct. Yeah, no, they were in a catch-22 for sure.
They should,
but they've always even before they put it in short term, they've always historically underpaid people. It just wasn't
sure.
It wasn't as much of a problem.
I'm not arguing against that. That's sure, but that's places make more or less money. That's their business, how they differentiate and things like that. The other thing that happened was they had the limits of how big a bank needed to be in order to get like extra auditing on them had been raised from 50 billion to 250 billion, which meant that SVB was not in that camp anymore. And if they had still had the extra auditing, they just would not have been allowed to have that much exposure to interest rates in the first place, which would have been a good thing.
All right, this is great. 2 more questions. 1, what conspiracy theory do you believe?
What conspiracy theory do I believe? I believe that there has been a giant conspiracy to not grant pink its rightful place as a primary color.
Oh, okay.
Yeah.
I like that. Okay.
Pink, I was looking into another project of mine. I need to write a color picker. I was this data science thing I was doing. I wrote some visualizations for it to demonstrate like why this works better, why a certain thing works better, and then I fell down the rabbit hole.
Because classically, you put some red and white together and you get pink or something like that.
Yeah. That's bright red. Pink is a hue.
Okay.
Which is not bright red. Anyhow, I fell down this rabbit hole of going into color theory. And there's actually a color picker that I want to write that's in my list of projects to work on in my copious free time. So it turns out when people say CMYK, that stands for cyan, magenta, yellow, and black.
And how did that all even happen? Like when I was a kid, it was like red, yellow. Okay, yellow's constant, and blue, and all of a sudden cyan and magenta pushed out red and pushed out blue
a lot of the,
to take advantage. Like somehow they took over.
A lot of what happened is a lot of the stuff you were taught about color theory was wrong because it was based on what people had intuited from mixing dyes and paints, and it's very, very difficult to make dyes and paints of certain colors that are relatively easy to make using phosphors, actually.
Interesting. Okay.
So the truth is that the primary colors here's okay. The primary colors are white and black, which are actual colors. There's no such thing as not a color. There is gray is the neutral color, but everything has a color, right? There's white and black, and then there's things that all should be granted primary status, although depending on context, sometimes you say some of them are primary and others are secondary. But there's red, green, and blue are primary colors, and cyan, pink, and yellow are primary colors. And the reason it's called magenta instead of pink is screen printers in the 20th century didn't want people to think they were girly men, and so they called it magenta instead of pink. But if you look at what's considered,
it looks like pink. When you look at magenta, it looks like pink.
It's really weird. If you look at what the different colors are called, there's this big area that's pink and this one little island within it that's magenta. It's like, wait, that doesn't make any sense. I mean, yes, that's a very specific shade of pink is magenta, but the name for the hue should be pink. What everyone calls it is pink. And it was just homophobia and misogyny that caused this just utterly ridiculous misnaming of the thing.
Okay, interesting. This is great. Okay, last question we ask all of our guests. What conventional wisdom or advice do you think is generally bad advice?
I would say in dating, the advice of follow your heart is really awful. I think.
Okay.
I think
you should follow the data. You should do the data science project.
No. It's not. Okay. You should never date someone who you're not attracted to, but people act this romantic notion like it's a crime to apply common sense and good reasoning to picking partners. That's terrible advice. You should totally if there's really an issue with someone, you should take that seriously.
How do you think one should use their gut for picking a partner?
I would say your gut is very, very bad at figuring out who's a good person, like especially like who's honest, right? People get impressions of who's honest, which are outright wrong. Like con artists are much better at coming across as honest than honest people are. But what you should trust your gut on is, who are you attracted to? Who makes you excited? Who are you into? That's something that you can't overrule and that you can't just decide on. So there you should do it. But in terms of judging people's character and their reliability and things like that, you should not trust your gut. You should look at actual empirical experience.
Okay, this has been amazing. Thank you, Bram Cohen, for joining us on World of DaaS. I follow you at Bram Cohen on Twitter. I definitely encourage our listeners to engage with you there. This has been a ton of fun.
Thank you. This is, a lot of fun.